I am in our guided notes. I am going to go ahead and look at number 6 with you. It's down here. I chose number 6 because it's got a little of everything. It's got solving inequalities, graphing inequalities, and some of like the follow-up questions you see with these. So we are going to solve 2 times d plus 1 minus 3d is less than or equal to 2. Now in this first part of notes, hopefully you notice that when you're talking about solving inequalities, it is the exact same thing as solving equations. So now that you guys are equation solving experts from last week, you can use all the skills you were practicing last week with equations and apply them to inequalities. Now there is one extra thing to remember when you're solving inequalities, and that has to do with negatives. Of course, right? Our favorite, negative numbers. Anytime you multiply or you divide by a negative number, this inequality sign is going to flip. So when I say flip, I mean if it was a less than sign, you're going to flip it to greater than. If it was greater than, you're going to flip it to less than. It just changes direction. And there's a part earlier in the notes that kind of goes over why with an example. Looking at this inequality, the first thing we would want to do is over here with the distributing. So I would start off by saying 2 times d is 2d, 2 times 1 is plus 2, minus 3d is less than or equal to 2. One of the biggest silly mistakes I see students do is they just write equals because you're so used to writing equal signs at this point. So be careful you're keeping the inequality sign. The next thing we could do looking at this side is, hopefully you're saying combine like terms, which would be correct. We could go ahead and say 2d minus 3d. That's going to give you, well, 2 minus 3 is negative 1. So you can write negative 1d, but if you remember from pre-algebra, that 1 is not necessary. So we're just going to say negative d. I'm going to put that a little closer. So negative d plus 2 is less than or equal to 2. Next would be getting rid of our constant. So I could subtract 2 on both sides, and we get negative d is less than or equal to 2 minus 2, which is 0. Now on this problem in the past, I've seen some students stop here, but we are not done. Do you know why? We're not done because there's still a negative sign there. Remember, your goal is always to get the variable by itself, so that means getting just like a plain old d and not negative d. So looking here, our last step, remember before how we had said there's a negative 1 there? That's like negative 1 times d. So in order to solve, we would need to divide. You're not going to divide by d, you're just dividing by numbers. We need to divide by the coefficient, which was negative 1. Divide here, divide here. When we do that, just like always, we're dividing so that we get our variable by itself. Negative 1 divided by negative 1 is positive 1, positive d, which is what we wanted. 0 divided by negative 1 is 0. And in between them, what have you written on your page? Have you written greater than or equal to? Now look, we divided by negative. That's what we had said earlier in this video. If you are multiplying or dividing, in this case we're dividing, by a negative number, that inequality sign needs to change. So our final answer would end up being d is greater than or equal to 0. Now in this question, that is the first part, part A. So part A, we've got d is greater than or equal to 0. The second part asks us to go ahead and graph it. Now nope, that's not going to fit. We'll try it higher. As I'm drawing a number line for us, think about if I say d is greater than or equal to 0, what numbers am I talking about? What numbers are greater than or equal to 0? Well, hopefully in your head or loud, no judgment, you are saying, well, numbers greater than or equal to 0, that's 1, 2, 3, 4, 5, and up, right? That's greater than 0. That or equal to 0 means it could also be 0. So it could be 0 or 1, 2, 3, 4, 5, and up. What you're listing right now is what we would want to show on the number line. So if you wanted to graph this on your number line, I'll just fill in some numbers. We would start with this number here, with our 0. And think back to when I had you list me numbers. If you say D is any number greater than or equal to 0, that means it can be 0. To show that it can be 0, we use a closed circle. Now we want numbers that are greater than or equal to 0. Well, we've got the or equal to 0. Now to show the numbers greater than, you shade all the numbers greater than 0, which would be all the numbers this way. In order to shade, you can kind of color it in like that if you want. In class, sometimes I do like weird squiggly lines. You can do that. I don't care. But something showing it's going to be the numbers on that side. That's showing the numbers we had listed before, like 1, 2, 3. It's also showing all those numbers in between, right? Like 1.5 is greater than 0. 0.7 is greater than 0. So it includes everything, including 1, 2, 3, and up. Now with that closed circle, you could have had a similar problem like D is greater than 0. If I say D is any number greater than 0, it's still all these other ones. But when it comes to 0 itself, 0 is not greater than 0. So that's why for just a greater than sign, it would have been what we call an open circle. An open circle says, hey, I'm talking about all of these numbers here, but when we get to 0, I'm not including 0. That is the difference between open and closed circles and how it goes with greater than or equal to and then just greater than signs. Understanding not just how to graph these, but also what it's saying is really helpful and important for questions like part C. In part C, it asks, can D equal 3 for the inequality above? Well, we've done a lot of talking about what numbers D can be. So you could always use that original answer, D is greater than or equal to 0, and use that to kind of help you decide, can D equal 3? Or you've got this beautiful number line graph right here that you can use. Remember, we were shading all the numbers that D can be. So if I'm asking you, can D be the number 3? Well, 3 is right here. It's shaded. We were shading all the numbers D can be, so why, yes, D can be the number 3. It's just kind of like a comprehension question to check to see, do you actually understand what this graph is saying? Hopefully this was helpful for you as you're looking at some of the other problems on how you solve inequalities, how you graph inequalities, and how you answer questions like this. I hope you all are doing well. Please stay home if you can. Stay safe. Hope your family's staying safe and healthy. I miss you all, and I hope to see your faces soon. Thanks. Bye.